Happy Monday. Woohoo. Guess what, guys? Today is the last lesson we are going to learn. So you have until Wednesday to finish up this. You'll get the review and then the Unit 10 test. So we are almost done, guys. Good job. All right, so we are talking about derivatives. So before we get to that, if we were in a normal class, I would make you do this little warm up, especially since we just got done with the weekend. So find the equation for the slope of 2x squared minus 3x plus 4 at any point. So as a reminder, what we have to do to find that is to use the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, so when we plug that in, first of all, I need 2 times x plus h squared minus 3 times x plus h plus 4. That's my f of x, and then I have to, my f of x plus h. Now I have to subtract f of x, which is 2x squared minus 3x plus 4, and divide that by h, and then all of that is as the limit is approaching 0. Okay, so you can go ahead and work through that. I'm actually going to pause it from my end and just kind of work through it so that I don't have to talk the whole way through, and hopefully we end up with the same answers. Okay, so I did all the work. I'll come back to that page. I just wanted to give you an opportunity, maybe if you wanted to pause it, just to try it out yourself. But here we go. Here's the answer to it. Okay, so once again, we use the limit formula and we plug that in. So when I plug that in, I get x plus h squared. I need to distribute that out, combine all my like terms. So as we can see, what I'm going to end up with is 4xh plus 2h squared minus 3h. I need to factor out the h because I'm going to find the limit as h approaches 0. So I factored that out, the h's cancel. Now I can find the limit as h approaches 0. So I do end up with my final answer is 4x minus 3. So that will allow me to find the slope at any given point. Okay, so if I wanted to find the slope at 7, now I can plug in 7. I get 28 minus 3, so the slope at 7 would be 25. Okay, so that is, a little bit of work there. Okay, so what we are finding is what's called the derivative. So in the previous section, we used limits to determine the slope of a line tangent to the graph at any given point. That's the warm-up problem. This is called the derivative. Okay, there is a much quicker and easier way to find the derivative. I don't know if somebody's maybe figured out the little pattern to it yet, but yeah, here's my memes, guys. Yes, there is actually an easy way to do this. Okay, because would we really want to find the slope with that formula that I was given? Literally, if we were trying to do that, we would be finding the limit as h approaches 0, and I would have to plug in x plus h and take that to the 6th power, minus 7 times x plus h to the 3rd power, plus 8 times x plus h to the 2nd power, minus 2 times x plus h, minus 10. I'm running out of room there. And holy moly, I would not want to do this. So there is an easier way. I'll come back to this one in a sec. But let's go through what the easiest way to find a derivative or to find the equation of the slope of this line at any given point. All right, I'm trying to get to my next page here. Struggling, guys, struggling. Where is it? There we go. Okay. Oh my goodness, that is not the right one. Let me pause it and get back on track here. Somehow I just jumped to, our sequences problems. Here we go. All right. Yeah, are you kidding me? Is there an easier way? Yes, I'm not kidding. Yes, there is an easier way. Okay, so this is what's called the power rule for derivative. So when you're given a function f of x when x is equal to the nth power and n is a real number, then the derivative, which is f prime of x, basically what happens is that power drops to the front and then we subtract 1 off of each exponent. That is literally how you're going to find a derivative. So let's start off with an easy one. What's the derivative of the function? So once again, if we were using the actual limit rule for this as h approaches 0, we would have to take x minus h to the 5th power, distribute all that out, minus x to the 5th divided by h, and find the limit of that. Well, the fastest way to do this is literally taking my power, dropping it to the front, and then subtracting 1 off of that. So the derivative of x to the 5th is 5x to the 4th. And if you simplified this, if you took the limit as h approaches 0 and used the limit formula for that, you would end up with this exact same thing, 5x to the 4th. Yeah, it's that easy, guys. It is that easy. All right, so finding the derivative of the function. Okay, so this would be another way. It'd be a little tricky in order to use the formula, but we are taking the function g of x. You're going to want to convert that to exponential form. So that would be x to the 6/4, or that's the same thing as x to the 3/2. All right, so what do? We're going to we're finding our derivative. So I'm going to drop the exponent 3/2 to the front and take 3/2 minus 1. So my derivative is 3/2 x to the 1/2. That is the derivative. That's it. 3/2 x to the 1/2. Okay, that's it. Okay, now, what if I have something in the denominator like this? Well, let's convert it to this right here. So h of x to the -10th power, so that I can apply the power rule for this. So the 10 drops, -10, excuse me. Then I have -10 minus 1. So that's -10 to the -11th. And now we will get rid of that negative exponent. So I have -10 over x to the 11th. That is the derivative. I guess that was an h, not a g. H. All right. Moving along. This one's multiple choice. So if you want to pause it and try and work out the answer really fast, you can go ahead and do that. I'm going to pause it, work out the answer, and then show you the work for it. Okay, so here's the work. So 1 over the cube root of x is the same thing as 1 over x to the 1/3, which is the same thing as x to the -1/3. So I drop the -1/3, I subtract 1 off of the exponent, so that gives me -1/3 x to the -4/3, which gives me -1 over 3 x to the 4/3. Then I convert that to exponential, or excuse me, radical form, so my answer is letter A. -1 over 3 cube root of x to the 4th. Okay, so we just done monomial terms for now, but the power rule applies for all exponents. Okay, so I'm going to rewrite this really quick. So f of x equals -5x to the 3rd plus 2x squared minus 12x plus, because I'm going to put in a 0 power here. Okay, so I have 3, 2, 1 power of 0. Because a lot of times people are confused at where the 15 is going to go. Okay, so we have a -5 out in front. I'm going to drop the exponent of 3. So then that means I have 3 minus 1. I have a 2 out in front. I'm going to drop the exponent of 2. And then I have 2 minus 1. I have a -12 out in front. This is an exponent of 1. So I'm going to multiply that by 1. That gives me 1 minus 1 plus 15. The exponent of 0 is getting dropped. And then 0 minus 1. Okay, so I end up with a -15 x squared plus 4x minus 12. This is x to the 0 power, and anything to the 0 power is 1, so I can get rid of that. And then I have plus 15 times 0. Well, 0 times anything is 0. 0 times x to the -1 is still 0. So my derivative is -15x squared plus 4x minus 12. Okay, so we're finding the derivative of -3. So basically this is equivalent to saying what is the slope of the line tangent at x equals -3. That's what this is asking basically. So we would want to find the slope of a line at any given point, which is the derivative, and then find -3. So once again, I'm going to have 6 times 5, x to the 5 minus 1, minus 4 times 3, x to the 3 minus 1, minus 2 times 1, to the x to the 1 minus 1. Whoops, I put 10 in there for some reason. 1 minus 1 plus 5 times 0 times x to the 0 minus 1. So I end up with 30x to the 4th minus 12x squared minus 2. And that 0 is there. So there's the derivative. And then I'm going to find f of negative, or the derivative of negative 3. So now I can just plug in negative 3 into this to find that slope at negative 3. All right, I'm going to pause it so I can calculate that. Okay, so I end up with the slope of the line at negative 3 is 2,464. 2,464. So it's a very steep slope. Okay. All right, so given the function, find the derivative. So that means that you're finding the slope at any given point. Okay, so hopefully at this point, I don't need to show all the work. This should just be 10x to the 4th minus 3x squared. That's it. Boom. Answer. 10x to the 4th minus 3x squared. Okay, finding the slope at negative 1. So let's find the derivative first. All right, so if you want to go ahead and pause it and find your answer, I'm just going to pause it as well for myself, work out the answer, and then you can check it with mine. Okay, so take a moment to do this problem. I guess maybe check to make sure that you converted correctly first of all. Okay, so I have negative 4x to the 6th minus 4x to the negative 4. So you need to get rid of that negative, or bring that up and make that a negative exponent. Convert this to a rational exponent, so minus x to the 1/2 plus 4. Now find the derivative of that. Okay, so the derivative is negative 24x to the 5th plus 16x to the negative 5 minus 1/2 x to the negative 1/2, and then that plus 4 is gone because that was a 0. So don't forget to subtract the exponents. Just wanted to make sure that you got these exponents correct. Okay, now I don't need to simplify. I'm just trying to find the slope at negative 1. So at that point, we can plug in a negative 1 into this. So 5th plus 16, negative 1 to the negative 5 minus 1/2, negative 1 to the negative 1/2, and calculate that. Whoops, hit the wrong key again. There we go. Okay, so I'm going to use my calculator, so I'll be back in a moment. Okay, so upon trying to calculate this, I just realized that I'm trying to take in this problem a square root of a negative there, which isn't possible. So that must mean if we graph this, there isn't actually a point at negative 1 on this graph. So I must have changed this last year to a positive 1, but you get the idea. So again, I can't take the square root of a negative here, but you know, if I did change that to a positive 1, then it does work. But yeah. So anywho, I'm just realizing I'm rambling on and that I could change that for your notes, but anyway, we'll go with this. I'll just leave it. So let me pause it one more time so I can actually calculate it. Boop-a-doo. Sorry, wrong key. Okay, so if we did change that to a positive 1, you do get a positive a negative 8.5. So that's what it is at negative 1. Okay, so we are at about 13 minutes. Again, this is the last lesson, so let's keep it moving. Okay, so derivatives of products and quotient rules. So the derivative of a product's actually pretty straightforward. You could really just distribute and then find the derivative there. So, you know, if we distribute this, I end up with a 10x to the 4th minus 6x to the 3rd, and then find the derivative of that. So our derivative is 40x to the 3rd minus 18x squared. Pretty straightforward. Okay, now derivative of a quotient is, of a monomial quotient, I should say. Again, pretty straightforward. You would actually want to go ahead and simplify this. So that means that you're taking 3x to the 3rd. And the rules when you're dividing by a monomial is that each term gets divided by that monomial term. Okay, so that's a basic Algebra 2 concept. So I end up with 3x squared minus 2x plus 1. and then we're going to find the derivative of that. So that's 6x minus 2. So there's my derivative of that function. Again, pretty straightforward when it's a quotient of a monomial. All right, okay, combining it, I would probably distribute first and then divide by the monomial term. So once again, this is a multiple choice. I'll go ahead and maybe if you want to pause it, make sure you get the correct answer, and then come back and check it against mine. So pause it. Okay, so you're back. So once again, we're going to take and convert that into a rational exponent. So I get 2x to the 1/2. So then I'm going to distribute the 2x to the third. I end up with a negative 8x to the fifth plus 4x to the 7/2 over 4x squared. Divide each of those. And when I divide it, I get this. And then I take find the derivative of that guy. And so your answer should be C. Okay. Okay. Okay, so the product rule for derivatives is, it is this formula. So basically what it's saying is if you're taking two functions, f of x and g of x, and you're finding the derivative of that product, you can find the derivative of the first function times the second function. So derivative of the first times the second plus the first function times the derivative of the second. Okay, so let me show you an example here. Went through and actually just typed this out because I'm going to be honest, guys, I don't actually use the product rule to find the derivative. I just go ahead and distribute and then find the derivative. Okay, but you can use this formula. So the formula would be, again, the derivative of the first function. So we have f of x. So f of x is your first function. So we find the derivative of that. And then I'm going to go ahead and find the derivative of the second function. So here's the second function. Find the derivative of that. I get this. So the rule for it is the derivative of the first function times the second function untouched plus the first function untouched times the derivative of the second function. Distribute all of that out and combine like terms. Okay, so that's the derivative of the product. I, again, don't actually use this formula. I'm just saying it's there. But it's just as easy to go ahead and distribute, first of all. So I have x to the fifth minus 2x to the fourth plus 3x to the third minus 4x squared plus 8x minus 12. So there's nothing really to combine. So then I find the derivative. So I end up with 5x to the fourth minus 8x to the third plus 9x squared minus 8x plus 8. Is that the same answer we got before? Yes, it is. So we get the same answer. It's a lot faster actually to do it that way. However, for the quotient rule, it is actually way easier to use the actual rule for it. So here is the quotient rule for derivative. So if it's not a monomial term, okay, so if it's not a monomial term, like the first example back up here, finding the derivative of a monomial, yes, go ahead and just divide it and find the derivative. That's much easier. Okay, but if we don't have a monomial rule or a monomial denominator, we are taking the two functions again, so we're splitting it. We have a f of x over a g of x. The rule is the derivative of the first function times the second function untouched minus the first function untouched times the derivative of the second function over the over the second function not touched squared. Okay, so that is the formula for the quotient of non-monomial denominators. Okay, so I actually went through and just did the work this way, kind of can explain it. So finding the derivative of the function. So again, let's go through the formula. Derivative of the first function. Here's the first function. The derivative is 12x squared. Okay, we're going to need the derivative of the second function here shortly, so we'll go ahead and find the derivative of the second function, which is 2x. and then we're just plugging that in. Okay, so it is on the next slide, but what it would look like is 12x times x squared minus 2 minus 4x to the third times 2x over x squared minus 2 squared. Okay, so once again, derivative of the first untouched, or second untouched, derivative of the second untouched squared. Okay, so got all that. Distribute. So distribute, multiply, get this, and combine like terms. Here is my solution. That's the derivative of the quotient. Oops, I just put the answer up there. That wasn't supposed to be there. Oh well. Anyway, so going through the work on this guy, so it is the derivative of the first, which is 2x, times the second untouched, minus the first untouched, times the derivative of the second, over the second untouched squared. Distribute, combine like terms, and you should end up with this guy. Letter A. Okay. So your last assignment is one more Delta Math. Once again, you have until Wednesday to finish this. You will then get the review and then the test, and then you're done. Have a good day.